goodness, we are on day 2 of material, and I am making videos for my sweet little kids. So, didn't want to write that, but let's look at this. I've had numerous questions about graphing the middle column. Everybody understands how to graph the first column. I'm still going to go over that. Everybody understands how to graph the last column. I'm still going to go over that. But there's confusion about that middle column. So, let's get to it. This first one, I have a square root function. This is just for my own benefit. I always like to graph the parent function so then I can see visually this moving horizontally and vertically. This is especially true when we get to dilations. I like to see that happen. So let me get my pregnant body comfortable. On this side, I'm just going to put it over here. Black is going to be my parent function. This is a square root function. I'm emphasizing it because I have the square root symbol right there. X, Y. Remember, with square roots, we start at the origin. And then I'm interested in all of the perfect squares for X and what their square root is for Y. And 3. There we go. This is my basic Y equals square root of X. That's my parent function. Now, let's do blue. Looking at this, I always start with my K. That's just me because I know my K is going to tell me exactly what is happening. K is on the outside. Because it's plus 2, I know I'm moving up 2. This H value, I know it's H because it's inside this entire quantity. And remember, our basic our basic parameter change, we have, and just go with me on this, I'm making it basic. Y equals A times F of B X minus H plus K. Where F is some type of parent function. I'm just saying it's some general type of function. My signs match up, so that tells me I'm substituting in a positive value for H. I'm looking at a positive 3, and because it's positive, I know I'm moving to the right 3 units. Taking my original parent function, I'm going to look at X plus 3, I'm moving to the right, and then it's going to be Y plus 2. This is also going to help me for the next one, and you'll see why. 0 plus 3, 3, 4, 7, 12. I know this one is going to be off the graph, so I won't graph it. And then I have 2, 3, 4, 5. So this f of x equals the square root of x minus 3, and then outside plus 2 is going to look like this. I'm going to start at 3, 2, go up to 4, 3, and then I have 7, 4. Extend this out. I know it's going to be something like that. So this is my f of x function. Here's the clarification now. I'm going to do this in this kind of purpley magenta. G of x. I'm interested in g of x. And it's telling me my parameter changes are coming from that f of x equation, which was 3, 2, 4, 3, 7, 4. I am now going to alter this line. We already have our table for this. So I'm going to look at each of the pieces. K. That's my up and down. That's my vertical translation. I know I'm going to go down 1 unit. My H, it now says plus H, so I know I have a negative term there. I'm going to go left 2. My new table is going to be x minus 2, y minus 1. And I'm looking at this blue table. 3 minus 2, 4 minus 2, 7 minus 2, 12 minus 2, 2 minus 1, 3 minus 1, and so on and so forth. So for this equation, again, in this kind of magenta-y color, I'm going to graph it. I have 1, 1, 2, 2, 5, 3. I almost put it in the wrong spot. My goodness, 10, 4. Like that. G of x is taking that first graph and then applying the parameter changes of left 2, down 1. Quickly on this last one. This is quadratic, so I know I'm dealing with my parent function. Oops, I'll put it right there. Sketch it in. Beautiful. Sketch it in. Beautiful. X, Y, negative 2, negative 1, 0, 1, 2, 4, 1, 0, 1, 4. Okay, that's my parent function. Looking at this one, I want to use red because I want to use a different color. This tells me down 4. This tells me left 5. And because of that, I'm going to do x minus 5, y minus 4. So I have negative 7, negative 6, negative 5, negative 4, negative 3. And then I have, my dog's bothering me, sorry. Greta, go away. Then I have 0, negative 3, negative 4, negative 3, 0. So let's graph that. Negative 7, 0. And I have negative 3, 0. Why not do them both at the same time? Negative 6, negative 3. And I have negative 4, negative 3. And then I have negative 5, negative 4. Just to help me graph it, I'm going to do one more point. And right there. This is my y. Okay, let's do another one. H of x. We are looking at an absolute value original parent function. So I know I have a positive slope of 1 on one side. I have a negative slope of 1 on the other side. Just getting my table in there because that's going to help me with the second graph. X, Y, negative 2, negative 1, 0, 1, 2 is 2, 1, 0, 1, 2. For this graph, I'll do blue. It's telling me down 7. It's telling me left 2, which is x minus 2 and y minus 7. Negative 4, negative 3, negative 2, negative 1, 0, negative 5, negative 6, negative 7, negative 6, negative 5. Okay, graphing this. Negative 4, negative 5. Right here. Negative 3, negative 6. And here. Negative 2, negative 7. And then I'm just going to bounce it back up. Extending this out. I don't have a ruler. This one doesn't do nice, beautiful lines for me. I apologize, my dogs are going to bark. Okay, this next one, I am taking my original h of x, which is the blue, and I am moving it up 8 and right 3. The reason why it's right Again, I have x minus h, keeping it still x minus something. I know I'm substituting in a positive 3. So I have x plus 3, and then I have y plus 8. Looking at that from this blue table, minus 1, 0, 1, 2, 3, and then I have 3, 2, 1, 2, 3. Let's graph it. Negative 1, 3, 0, 2, 1, 1. I forgot where I was. 2, 2, 3, 3. Filling this one in. I have this, and then I get something like that. Okay, red. Square root function. We already know what our table is. We already know what our original graph is going to be. So I'm just going to plug that in. This is my parent function. Do you have to draw this? No. Why do I? It helps me see it visually. It helps me see what I'm doing. So my table, x, y, 0, 1, 4, 9. 16 is not going to be on the graph. I'm not going to do it. 0, 1, 2, 3. Now, looking at this, up 6, my negative stayed a negative, so I know I'm going right 5. So I have x plus 5, y plus 6. 5, 6, 9. Well, this would be 14. I'm going to put it down just in case. And then I get 6, 7, 8, 9. 5, 6, 6, 7, and then I have 9, 8. So this red graph is my y. I'm not going to do R for you. I want you to try to do it and see if you understand it. Let's look at the next page. This is exactly the same thing. I have given c of x. This whole graph right here is my c of x. And what is it telling me to do? It's telling me to apply these parameter changes to get d of x. So this is saying I'm going to go down 7 and I'm going to go right 5 units. Before I start that, I need to know what these points are. So let's make a table. X, y, this is for my c of x. That's negative 7, 5. And then I have negative 4, negative 2, negative 3, 0. And then if you want to do this, negative 2, 1, negative 1, 0, 0, 2. Oh no, we're running out of room. And 1, 2, 3, negative 2. 3, negative 2. To graph this first one, I'm going to take my x's, add 5. I'm going to take my y's, subtract 7. Negative 2, 1, 2, 3, 4, 5, 8. Subtracting 7, I get negative 2, negative 9, negative 7, negative 6, negative 7, negative 5, negative 9. And I'm just going to graph it. Yours will look a little bit different just because we have squares here. The other one, they were more rectangles for each of the grid. So I have negative 2, negative 2. 1, negative 9, all the way down here. Just going to connect it. 2, negative 7 comes up here. 3, negative 6. 4, negative 7. And this is a curve. 5, negative 5. 5, negative 5. And then 8, negative 9 down here. So that's what my graph is going to look like. Again, This one looks like it's scrunched in more just because we do not have the same shape of grids. Last bit. I have all of these, and it says, given the following graph, write the equation, then state the domain and range. Let's look at this first one. The first thing I need to know is that this is a square root parent function. So I have y equals the square root of x, and I'm not going to do anything else. I'm going to leave it as it is. My original starting point is the origin. So this is going to tell me I go down 1, 2, 3, 4, 5, minus 5, and I go to the left 1, 2. Because this is going to the left, remember I have minus and then my direction. What's minus and negative make it? I hope you're screaming at your computer. X plus 2 minus 5. So this is our actual equation. Oh, that's just a glorious poop brown yellow. On this one, my domain, I'm going to do it in interval notation, not inequality. I'm actually hitting that point at -2, and then I go on for infinity. My range, the lowest point I have is right here. I actually hit that point, and then I go on to positive infinity. Let's do one more. Let's look at this bottom middle one. Didn't we say something about quadratics, vertex notation? That's essentially what perimeter change is. Keep that in your brain. Here's my vertex. I know I start at 0, 0. I go down 1, 2, 3, 4, 5. So I know I'm subtracting 5. This is a quadratic. So I have something like this. It's going to start with x, and then I'm moving 1, 2, 3, 4, 5, 6, 7 to the right. So it's minus 7. Let's just do inequality and notation. Why not? So wasn't this all real numbers? Negative infinity, less than x, less than positive infinity. The range is different. I start at this point down here, and I go on forever. All the way up. So my range is going to be the lowest point, which is -5. I actually touch it, so less than or equal to y less than infinity. I hope this is helpful. We need to understand what the specific notation means.